Today we're going to look at direct and inverse variations, which is in section 5.6 of your BJU Press Algebra 1 textbook. So let's begin with looking at the distance formula, which is d equals rt. So remember, d equals the distance, r is the rate, and t is the time. So the formula is basically saying that the distance traveled is equal to the rate that you're traveling at times the time that you spent traveling. So we're going to use this formula to answer the question, find d, distance, if your rate is 55 and your time is half an hour. So what we'll do is we will plug 55 and 1/2 into our formula, and we get d is equal to 55 times 1/2. So half of 55 is 27.5. Now let's find our rate if our distance is 171 and our time is 3. So this time we have 171 is equal to r times 3. So to solve for r, we divide both sides by 3, and we get 57. Now let's find t if our distance is 260 and our rate is 65. So this one would look like 260 is equal to 65 times t. So to solve for t, we would divide both sides by 65, and 260 divided by 65 is equal to 4, which means that our time is 4. Now another one, we have find distance if our rate is 45 and our t is equal to h. So for this one, we don't have numbers to multiply together. All we have is d equals 45 times h. So we can't really multiply 45 times h, so we end up with this 45h. Now we have find time if distance is 630 and rate is equal to s. So our formula would read this: 630 equals s times 630 equals s times t. And since we're trying to solve for t, we have to divide both sides by s, which means that we have t equals 630 divided by s. Alright, now that we have gotten warmed up on using formulas and solving for variables, let's take a look at our first definition, which is the definition of a direct variation. A direct variation is a function in which the ratio of variables is a non-zero constant. So that means that every time that you do y divided by x, you get a k value where k is not equal to 0. The quantities are said to vary directly or to be directly proportional. So when you have a set of numbers and every time you do y divided by x, you end up with the same number over and over and over again, that's when you have a direct variation. And that constant k is also called the constant of variation because it reappears every time. And it's also another word called a constant of proportionality, is that k value. Alright, so our formula for direct variation is that y equals k times x. So remember that k is that constant of variation or constant of proportionality. So remember, in order to know that it's a direct variation, we'll do y divided by x and make sure that it equals k. So our formula for direct variation is y equals k times x. So anytime you have a function that looks like y equals k times x, you have a direct variation. And remember, since y is the same as f of x, it will look like f of x equals k times x. In most cases, our k is going to be greater than 0. Our constant will be bigger than 0. Let's look at an example. I need you to go ahead and turn to your textbook on page 215, and we're looking at example 1. There's a table in example 1, and it's on the far right-hand side. And the question is, does the table represent a direct variation? And if it does, find the constant of variation and write the function rule. So if we're looking at the table, we notice that when x is 1, y is 7. When x is 2, y is 14. And when x is 3, y is 21. When x is 4, y is 28. So remember, the rule on to figure out if a function is a direct variation is if every time we do y divided by x, we end up with the same k value. So let's take a look at it. Let's do our first two numbers. 7 divided by 1 is 7. 14 divided by 2 is 7. 21 divided by 3 is 7. 28 divided by 4 is 7. So since every time we divided y by x, we got 7, we can say, yes, our ratio of y to x, or y divided by x, equals 7 for every ordered pair, which means that the table does represent a direct variation. Not only does it represent a direct variation, but since every time the ratio of y to x was 7, our k value, or our constant of variation, or our constant of proportionality, is also 7. And since we know what our k value is, we can write our function rule. Because remember, the function rule of a direct variation is y equals k times x. Since we know our k is 7, that means our function rule would be y equals 7x, or f of x equals 7x. All right, now I want you to turn on your textbook, and I want you to take a look at example 2, which is page 216. It's going to be at the top. And example 2, you are trying to find the constant of variation, which remember is that k value, if y varies directly with x, and y equals 6 when x equals 3. And then write the function rule for the variation. So there's two problems here. So you have to find the constant of variation and then also write the function rule. So to find the constant of variation, we're trying to find our k value. Well, remember, our k value is the ratio of y to x. And since we know that y is 6 when x is 3, we can find that ratio. It's 6 over 3. And since 6 over 3 is 2, that means our k value, or our constant of variation, is 2. And now when we want to write our function rule, remember our function rule is y equals kx. And since we know that our k is 2, our function rule is y equals 2x. All right, so let's talk about the thought of proportions for a second. So since the ratios in a direct variation are always the same constant, the ratios have to be the same, and that means that they're proportional, which means that we can use the rules of proportionality on them. Let's take a look at example 3. So remember, the rule of proportionalities is just that you set your ratios equal to each other and you can solve for missing information. On example 3, which you're going to need to turn to your textbook, page 216 to write down, example 3 says, if the distance traveled varies directly with time and Jose rode 12 miles in 45 minutes, how far can he ride in 2 hours? So for this one, your ratios are distance to time, right? And so what we can do is we can write a proportion. Distance 1 over time 1 equals distance 2 over time 2. So, and then we can plug in our information. So I noticed that he has 45 minutes and 2 hours. So we have minutes and hours. So we need to rewrite 2 hours into minutes. We have to convert 2 hours to minutes. So since there are 60 minutes in an hour, 2 hours is the same as 120 minutes. And then we can fill in our information. Our D1 was 12 miles. Our T1 was 45 minutes. So we have 12 over 45 equals, we're trying to find our second distance, or D2, over, we know that he did it in 120 minutes. So now we can use our rule of proportions to solve the proportions. You can cross multiply, and you get 45 D2 equals 12 times 120, which is 1,440. Divide both sides by 45, and you get that D2 is 32 miles. All right, so let's talk about another thing in direct variation. In direct variation means that you are increasing the other variable, right? So y is increasing. And that only happens when your k is greater than 0, because when you're thinking about it, if to get your k value, you're taking your y and you're dividing by x, and if you end up with a whole number, that means that y was bigger than x, which means that your y is increasing. All right, now let's take a look at the opposite of what we have just learned. So when we have an inverse variation, the ratio of variables is not constant. So we can't do y divided by x and get the same number every time. So that is called an inverse variation. And that's when the product of the variables is constant. So when you keep multiplying x and y and you keep getting the same number, that's what we call a inverse variation. So in order to get our k value, we have to do x times y. And that gives us our constant of variation for an inverse variation. So an inverse variation is where the product of the two variables is our constant k. So it'll look like this. X times y equals k. So in order to see if it's an inverse variation, we take a look at the x's and y's and look to see if we still get the same number when we multiply them together. That's how we find our k value. So we call those numbers that they vary inversely, or they're inversely proportional. And the constant k is still called the constant of variation. So in order to write the inverse variation, remember it was x times y equals k, and that's how you found your k. But if you're looking for the function rule, it would be y equals k over x, because you're solving for y, because that's how we write functions, is y equals, or f of x equals. And then the same as direct variation, your k value is usually going to be greater than 0. So when k is greater than 0, there's an increase in one variable and a decrease in the other. Let's take a look at example 4. Example 4 is on page 217, so you'll need to go there so you can write down this example. It says, does the table, which is on the right, represent a direct variation or an inverse variation, or neither? If it is a variation, find the constant of variation and write the function rule for the variation. So there are 3 things we have to do. The first thing we do is we have to test if it's a direct or an inverse variation, or neither. And then we have to find the constant of variation, and then we have to write the function rule. So there are 3 things that we're trying to do. So to test it, we have to look at the rules to find k. So remember, if it was a direct variation, we would do y divided by x to find k. So we can test our numbers, and we can test to see if they end up adding up, or end up being the same thing. So 72 divided by 2, 36 divided by 4, 18 divided by 8, 12 divided by 12, 9 divided by 16. They're all supposed to be the same number, but they're not. So since the ratio of y to x is not constant, this particular example is not a direct variation. So the next thing we can do is we can test for an inverse variation. So 72 times 2, 36 times 4, 18 times 8, 12 times 12, 9 times 16, 6 times 24, 3 times 48, they all end up being 144, which means that since that is true, we have an inverse variation. And since we have an inverse variation, to find our k value, we just need to do x times y. And remember we said that they all ended up being 144 when we multiplied them together. So that means our k value is 144. And then to write our function rule for an inverse variation, we're supposed to do y equals k divided by x. Well, since our k is 144, our function rule would be y equals 144 divided by x, which can be rewritten as f of x equals 144 over x, since f of x and y is the same thing. All right, so an inverse variation, since the constants are the same, we can also set those equal to each other. So for example, x1, y1 should be the same as x2, y2, since they're both supposed to equal the same k value. And since that's the case, we can use those to solve problems. Let's do that in example 5. You'll have to turn to your textbook on page 217 so that way you can see the example and write it down. It says the number of census workers varies inversely with the number of days it takes to complete the census in Pleasantburg. If it takes 24 workers 15 days to complete the census, how many workers are needed to complete the census in 10 days? So first, since we know it varies inversely, we can write in an equation for the quantities that are inversely proportional. So we can write, well, the workers for one census times the days for that one census is equal to the workers for our second census times the days in our second census. So that would look like this. W1D1 equals W2D2. And then we can replace our values. So it took 24 workers 15 days. So how many workers will it take for 10 days? Then we solve for W2 by dividing both sides by 10, and we get 36. In this inverse variation, the constant k ended up being 360 since W1D1 was 360. All right, so let's review. For direct variation, the definition is that the ratio is constant, or y divided by x. And it also implies that y1 over x1 equals y2 over x2. And the function rule was y equals k times x. And then the graph will look like this. Notice that the graph will go through the origin, always will go through the origin. Then let's review inverse variation. This one, the product is constant, which means to find our k, we have to do x times y. And that implies that x1 times y1 equals x2 times y2. To find our function rule, we'll do y equals k divided by x. And then the graph of an inverse variation will look like this. Notice that it doesn't ever go through the y-axis or the x-axis. Now that we've reviewed that, let's take a look at example number 6. You're going to have to turn to your textbooks for example number 6. It is on midway on page 218. And the question says, Hooke's law states that the length of the stretch in a spring is directly proportional to the amount of force applied to the spring. If a spring stretches 8 inches when a weight of 20 pounds is put on it, how far will it stretch when a 50-pound weight is put on it? So notice that it said that it is directly proportional, which means that it's a direct variation. And since it's a direct variation, we can use that law of proportions, y1 over x1 equals y2 over x2 to help solve our problems. So the first thing we want to do is write a proportion for the quantities that are directly proportional. So the spring 1 over the weight 1 equals the stretch 2 over the weight 2. We'll plug in our information, and then we'll solve for S2. So first we cross multiply, then we divide both sides by 20, and our stretch in the second case ends up being 20 inches. Go ahead and try some problems on your own.